Hey guys, this is week 2 for TRIG. We are continuing our graphing of our sines and cosines, and we're going to add some more transformations to our graphs today. So remember back in Algebra 2 where we started graphing and we started shifting things. That's what we're going to go back to for just a second. If I have this equation right here, I know that it's a parabola because it's squared. I know it's going to open down because of this negative right here. So this negative flips things. It reflects it about the y or the x-axis. Inside here, if I have an expression within those parentheses, that's going to be a horizontal shift. And we're not going to go back to, because of this negative, we're going to go forward to. So it's going to be shifting forward or right to 2 units. And then this plus 3, that's my vertical shift. So remember, we're going to go up 3. Well, we're going to take that same idea today and put it with the sine and the cosine graphs. So the forms that we're going to be looking at is y equals a times the sine, or remember, we are looking at cosine as well, of, here's where it starts changing, bx plus c plus d. Okay? Now, you might also see this. So the only thing different with these two forms is that d, that constant, is moved to the front. And guys, that's still a vertical shift. It's just located in a different area. Okay, remember, order does not matter when we add. Same is true for the inside of the parentheses. That bx plus c, that could be switched. You could have c plus bx. Okay, so just kind of be careful. Know that it's the same thing. Let's just kind of go through and let's talk about the different letters. And my dog is barking in the background, so I apologize for that. Remember, the a, or absolute value of a, even better, is your amplitude. And we talked about that last week. Amplitude, we said if the amplitude is 3, from the middle of my graph, I will go up 3 and I will go down 3. Now, in the previous week, the middle of our graph was that x-axis. So we would literally go up to -3, or up to +3 and down to -3. But now the middle of our graph is going to be changing based on if there's a vertical shift or not. We also talked about if your amplitude is 3, the distance from the very top to the very bottom of your graph is 6. So the same still holds true to that. We also introduced B last week. And remember, B affects your period. Okay, so it affects the period. And remember, your period is equal to 2 pi divided by b. Okay, so that period will continue to change. Now, I'm going to jump to D, and then we're going to come back and talk about the C part. We know that D is your vertical shift. So if it has a +5, my entire graph is going to go up 5. It's your vertical shift. It's the middle of your graph. Okay, it's the middle of graph. And from whatever D is, I said this already, you will go up and down from D, whatever your amplitude is. Okay, now C, if there is a C, there is a horizontal shift, or what we like to call a phase shift. Okay, so in TRIG, they don't really call it a horizontal shift, they call it a phase shift. Okay, now listen to me. Whatever C is, that is not necessarily your phase shift because you have this other variable in here with it. So to find your phase shift, you are going to take whatever that inside is and you are going to set it equal to 0. Okay, you will always set it equal to 0. Once you solve for x that will give you your phase shift. And we'll be able to see here in a little bit what I'm talking about, okay? And we'll explain it in a little more detail. All right, so let's look at an example. Let's go back to black. All right, so we are going to graph y equals -4 cosine of 5x plus 2. Okay, so let's just kind of go through here and talk about everything. There is a negative, so that negative we are going to reflect about the x-axis. Now, here's what that means. We're dealing with cosine. The original cosine curve that we are used to starts at a max, comes down, ends at a max. And that happens at 2 pi. Now, if I throw a negative in front, this whole thing is going to flip. So instead of starting at a maximum, it's going to start at a minimum. And it's going to go up and back down at 2 pi. Okay, so all that negative does is it's going to reflect that graph or flip that graph around the x-axis. So this right here is what our graph is going to do. Okay, I'm not sure what happened there. This is what our graph is going to do. Okay, only because it has a negative. Now, the amplitude is not -4. Remember, it's the absolute value of -4. So the amplitude is 4. So from the middle of our graph, we're going to go up 4 and we're going to go down 4. And we'll have a distance of 8 between the top and the bottom. Period. And I'm just kind of going down the list here of things that I see. The period, the b is 5. So remember, to find the period, we're going to take 2 pi and divide it by b. So our period is 2 pi divided by 5. So when we graph this, because this is a 5 here, I would count by pi over 10s or pi over 5s, something that's going to make this simple, okay? I wouldn't count like by a pi over 4. That's not going to work out that nicely. All right, so moving on. I know I have a vertical shift. Up 2, and that just comes from this 2 right here. So the middle of my graph is going to be at 2. All right, and the only thing we have not talked about is the phase shift. Okay, so here's the thing. This 5x, and they didn't have parentheses around it, but if I had parentheses, it would just be right here. There's no parentheses around this 2, so it's your horizontal or it's your vertical shift. We have no c, so there is no phase shift. There is no horizontal shift. So one thing that you're going to have to start doing on your assignments is endpoints of a period. So this is, where does your first period start and where does your first period stop? Well, we had no phase shift, so our first period starts at 0 and our period will end at 2 pi over 5. So that gives me a distance of 2 pi over 5, which is my period. Okay, and as we go further along, hopefully you'll understand that a little bit better. Okay, so let's start graphing. And again, I want to count by pi over 5s or pi over 10s because of my period. Apparently my lines aren't very straight. Let's try this again. I've got the line recognized. Hey. Okay, so the middle of our graph is now going to be up 2. So here's what I'm going to do. Let's call that 1. Let's call that 2. There's the center of our graph. Okay, so to make this a little bit easier, here's what I'm going to do. There's the middle of our graph. So it's kind of like our new x-axis. And from this line right here, we've got to go up and down 4. So our graph will need to go down to at least -2. And if I go up 4, it needs to go to +6. So let's fix that right there. So we said it needs to go down 1, 2, 3, 4. And then let's see. 1, 2, 3, 4. So let's see if I can extend this. Works good enough for me. Okay, so now we need to number our x-axis. And again, we want to count by nice numbers. Let's graph this from, let's say, -pi to pi. Let's say I want to graph this from -pi to pi. So if I want to count by pi/5s, I'm going to need 5 tick marks. So this would be 1, 2, 3, 4, 5. So this would be pi/5, 2 pi/5, 3 pi/5, 4 pi/5, 5 pi/5, which is pi. Okay. If I go, I better number this one too. Okay, so let's do the same thing going backwards. 2, 3, 4, 5. Okay, so this would be -pi, -3 pi/5, and -pi/5. Okay, so we know that, let me change this, one period starts at 0 because there was no phase shift, and it's going to end at 2 pi/5. Well, 2 pi/5 is right here, so that's kind of where that first gate is going to end. And then another 2 pi/5 would be here. Ah, yikes. Another 2 pi/5 would be right here. Yeah, that was bad. Let's try that again. We'll do this. And then right here. So I'm counting by 2 pi/5s because that's what a period is. Okay, so let's extend that. Pretend that's a straight line. Okay, so we're going to graph this. Now I've got a lot of different things happening right here. Again, remember, this line right here is the new center of my graph. And from here, I'm going to go up 4 and down 4. Okay? Now, because the negative in the very front, we said our graph is going to look like this. So our graph will start. Remember, this is going to be our new origin. I'm going to go down 4 because we're going to start at a minimum. My period is going to end at a minimum. Now, right in the middle of my period is a maximum. Well, remember, where does our max need to be? All the way up here, and it's right in the middle, so it's happening at pi/5. Now, if I look back over here, what happens between this minimum and maximum? It crosses the x-axis. Same thing here. In the middle, it's going to cross the x-axis. So in the middle, which this would be a pi/10, it's going to cross this x-axis. Okay? Right here, this would be 3 pi/10. It's going to cross the x-axis. So it looks like a very, very narrow V, but remember, it does have to curve. So let's try to do this as best as we can. Again, I hope your graphs look better than mine because this is scary. Okay, but basically now we're just going to repeat this. That's there. This is up at 4, back down, and you've got your graphing calculator. So guys, make sure you're putting this in the graphing calculator. Oh my, this is so bad, you all. Okay, so then right here, this is the middle, so I'm at the, okay, and now it's not an x-intercept. I think I said x-intercept here, but that's the middle of my graph, so that's where it has to cross. And if I'm stopping at pi, that means I'm going to stop at that maximum right there, okay? And my computer just recognized that as a straight line. So when I want straight lines, I don't get them. Okay, so then on this side, again, that's going to cross through the middle. Negative pi over 5 is going to be here, middle, and then back down. So there's another period. Oh, heavens. Okay. If it wasn't so narrow, it would be a little easier to graph. Oh my, this is getting bad. Let's start that piece over. Okay, and then here, and then here. Okay, there we go. And seriously. All right, there we go. It makes that a straight line, but it won't make my other line straight. All right, so there's your graph. Again, I would check this in your calculator. Make your window for x's negative infinity to positive infinity. Your y coordinates, and then you're counting by pi over 5s, or you could even put pi over 10s in there. Y coordinates, I would go at least from -2 to +6, but on the y's, we're counting by 1. So what I would do is I would pause this video, check your graphs, guys. Make sure you're not going to be able to tell me what these exact x-intercepts are because our graph has shifted, but you should be able to tell me key features such as the y-intercept, which would be -2. You should be able to tell me all the points of extrema, which are mins and maxes, okay? And if you have any questions, guys, don't forget you can email me at any time, all right? And I will post these on Oasis as well. These, not this particular one, but my paper notes. So it looks a whole lot better. Okay, so moving on, let's look at a sine curve, and we're going to get a little more intricate on this one. All right, so y equals -2 sine of 2 theta plus pi over 2 plus 1. Okay, so before every problem, I do want to see all of this written out. There is a reflection about x. Okay, so what does that mean for the sine curve? We know the general sine curve, so sine of x or sine of theta, starts at the origin, it goes up, and it goes down. So it has that maximum first. Well, when I throw a negative in front of there, that's all going to flip. Okay, so rather than going up, it's going to go down and right there. So this is what our graph will look like because it has a negative in front of it. Okay, so we're going to reflect about the x-axis. We have an amplitude of 2. And so I'm just going down the list. So we've talked about that. We've talked about the 2. Now, this right here, this affects our period. So remember, your period is 2 pi, Lord, over b. So I'm going to take 2 pi over, our b is 2, so our period is just pi. Okay, our period is just pi. I'm going to jump to our vertical shift. We have a vertical shift up 1. Well, so the middle of our graph will be up 1. Now remember, to find our phase shift, I'm going to take this part right here. So 2 theta plus pi over 2, and I'm going to set it equal to 0. And this is going to tell me where my period will start. It is not going to start on the y-axis like it has been. So I'm going to solve for theta here. If I solve for theta, I'm going to say 2 theta equals negative pi over 2. Okay, now I'm going to multiply by 1/2, which remember, guys, that is the same as dividing by 2. So those will cancel out, and I have theta equals negative pi over 4. Okay, so if it asks for a phase shift, your phase shift is negative pi over 4. Okay, and that's going to be important here in just a minute when we are graphing. Okay, now endpoints of a period. You just found out that your phase shift is negative pi over 4. That means that sine graph will move back to negative pi over 4. Okay, so that period will start at negative pi over 4. Now, to determine where it ends, so this is your starting point, and that came from here. To determine where the period ends, well, you just add the period to it. So I'm going to take negative pi over 4, and I'm going to add 4 pi over 4. Now, the 4 pi over 4, remember, that's just pi, and that came from my period. So that came from that right there. And that gives me 3 pi over 4. So my period is going to start at negative pi over 4, end at 3 pi over 4, and that's a distance of pi, which is my period. Okay? So all of this information is going to help me as I start to graph it. Okay, so I'm going to graph this one from, let's say, oh, it doesn't really matter. Let's go negative pi to pi. We'll graph this one the same as the last one. So let's go negative pi to pi. And on your assignment, it'll give you your domain that you're graphing from. So let's see here. The middle of my graph is up 1. Okay, so there's the center of my graph. That comes from this right here. So let me just kind of do a dashed line here across 1. Okay, so there's the center of my graph. From there, I'm going to go up and down 2, and that comes from the amplitude. So the highest I'm going to go is 3, so that's 3. The lowest I'm going to go is negative 1, and so that's going up and down 2 from the middle. Okay, now we're not going to start right here like we did on the previous problem, because we're shifted back to pi over 4. So what I would do on these, look at your period, look at your pi over 4. Let's count by pi over 4, something nice for us. So if I count by pi over 4s and I'm going from negative pi to positive pi, then this would be 1, 2, 3, 4. So here's pi. This would be pi over 4, 2 pi over 4, and remember that reduces 3 pi over 4, 4 pi over 4. So same thing here. This would be negative pi over 2, and again, that's just 2 pi over 4. All right, now our period. I'm going to get some more gates going. And there's a lot to take in on these, so just bear with me here. Remember, your period is going to start right here at negative pi over 4. So negative pi over 4 is right here. My period is going to start there. Basically, guys, this is your new origin. That right there is going to be our new origin. Okay? We've shifted back pi over 4, up 1. Back pi over 4, up 1. So there's your new origin. Now, that period will end at 3 pi over 4. So 3 pi over 4 would be right here. So we're going to see one full period. Okay? If I wanted to do another period, then I would take 3 pi over 4 and add pi to that as well. And you just keep going. You just keep adding pi to get your endpoints. Okay? But basically, I am going to have one full period right here, and then we'll just fill in our spaces. Okay, so let's graph. We said that one full period is going to look like this over here because there is a negative. So it's going to hit our new origin, and it's going to go down, and it's going to end at the new x-axis. So one full period, remember we said this is our new origin. Let's go back to a line here. Well, guess what? It has to end right where it started. In the middle, it goes through. So the very middle would be right here. It's going to go through. The first half of the graph reaches a minimum. Okay, so our first half of our graph is right here on the y-axis. It's going to hit a minimum, which we said would be -1. The second half of the graph, the middle is right here at pi over 2. Well, it's going to go up to 3. Okay, so this one isn't as narrow as the last one, so I can graph that a little bit better. So there's what this one period looks like. Now, look at your patterns. What is going to happen next? Okay, if I'm going to stop at pi, it's a whole tick mark. It's a pi over 4. Well, what's happening every pi over 4? Okay, this is the middle. So from the middle, it's got to go down here. Okay, so we wanted to kind of finish this pattern here. Right here, it's got to go up. Okay, next pi over 4, it's got to be here. And then there's that. Okay, now, oh yikes, I'm way past my minimum. Don't know what that is. Okay, so our minimum should be closer to right here. Oh, you are, good Lord. Okay, so, seriously, y'all, I'm not good at this. All right, so we just started with this one period right here, but if you'll look at this graph as a whole, we have graphed 2 full periods, okay? Right here, this first hump, and then it repeats again. There's your second hump. So we have actually graphed 2 full periods. We just started right here. Okay, there was the period that got us started. Again, go check this in your calculator. Your x's would go from -pi to +pi. Your y's would go from -1. Okay, we have one less problem. I'm going to try to go through this pretty quick. What I would do after you write down the problem is just pause it and try to work this out on your own and check it in the calculator. Then play this and see if you did it correctly. And hopefully that'll help you out just a little bit. I'm going to start at the very beginning of this, and this 3 is going to make my graph shift up 3 units. So if I were to graph this, the middle of my graph is going to be right here at 3. So let's make that dashed. There's the middle of my graph now. Oh, yikes. Let's try that again. Let's go forward, backwards. We're just going to go with that. And then from the middle of my graph, my amplitude, since there's nothing in front of here, my amplitude is 1. So from that 3, we're going to go up 1 and down 1. So this graph is only going to stay between 2 and 4. So your range is 2 to 4. All right. Now, if I'm moving over to this is going to affect my period. Okay. So remember, your period is 2 pi divided by b. Well, my b is not 4. That's in the denominator. So my b is 1/4. So my period will be 8 pi, and the 8 pi just comes from taking 2 pi and multiplying by your reciprocal. Now, I also know that I do have a phase shift because I do have an expression in there. So remember, to find your phase shift, take that inside part. I'm not sure what's happening there. So take that inside part and set it equal to 0. So now when I solve for x, I'm going to multiply both sides by 4. And remember, these are the nicer ones. So x equals 12 pi. Okay, and when I say they're the nicer ones, when they have the longer period, they're a lot easier to graph. Okay, now let's talk about this, because 12 pi, that means instead of starting here, we're going to start way over here at 12 pi. And that endpoint will go, or that of the period, endpoints of period, it's going to start at 12 pi, and it's going to go all the way to 20 pi. And the 20 pi just came from the period, adding the period to that first endpoint, which is just your phase shift, which means my next period will start at 20 pi and it will go to 28 pi. Now that is way off our graph, so go in the other direction. So now I know a period will end at 12 pi. We'll subtract 8 pi from that. So won't it start at 4 pi? Okay. Or a period will end at 4 pi. So where will it start? Negative 4 pi. And I'm only getting those numbers because they have to have a distance of 8 pi. Here, since this has 0 in it, here's where I'm going to start. And since these are such big numbers, let's just count by pi. So if I count by pi, and let's go from negative 4 pi to positive 4 pi, let's just graph one period here. So if I count by pi, there's 1, 2, 3, 4. So this would be 2 pi, this would be 4 pi. 1, 2, 3, 4, negative 4 pi, negative 2 pi. Okay, again though, this is the center of my graph. Now, it's cosine. There was no reflection. It's a positive cosine. So remember, positive cosine starts at a max, it ends at a max. Well, our max is going to happen right here. No, it's going to go up. Because remember, this is the middle of my graph. My amplitude, oops, I got that wrong. So I hope you guys caught that. My amplitude is 1, and that comes from the number in front. So from this middle, we're going to go up 1. And remember, one full period is going to end at 4 pi. So I'm going to end right there. In the very middle of my period, I'm going to have a minimum. So the middle of my period is right here on the y-axis. Well, our minimum would be right here. So that puts 3 in the middle of my graph. Okay, now in the middle of this half, which would be right at negative 2 pi, I'm crossing through the middle of my graph. Middle, middle. So it looks like an absolute value graph, but remember, this has some curvature going on. Okay, so there's what your graph should look like. Again, I would check this in the calculator. Email me, guys, anytime. Yes, I'm terrible at this. If you want to YouTube other videos, that is totally okay with me. You're not going to hurt my feelings. I will talk to you later, and I will see you soon. Thank you. Bye-bye.